for the second half, we'll look at three topics a bit more in depth. And this first topic, you've been also looking at the paper about net neutrality. And this is, let's say, one topic where politics, economics, web technology all get together. And sort of you need to look at this challenge from a bunch of different angles to say smart things about it, right? And that's also what we, hopefully train you to do, is to give you enough knowledge that you actually know how the technologies work to say smart things about what you think about net neutrality. And hopefully I'm not trying to tell you what to think, but to tell you how you can think about these. Okay, so what is net neutrality? So net neutrality is a term that came up around 2003 when there were all kinds of issues around access to the web and who should control it. So this is one definition from Tim Wu from Columbia University. So he says network neutrality is best defined as a network design principle. The idea is that a maximally useful public information network aspires to treat all content sites and platforms equally. So that's sort of often used version. For me, it's a little bit too vague, so I asked Tim Berners-Lee, well, actually, no, I didn't ask him, he just did it by himself, to explain to the public what net neutrality is. So the video quality is a bit bad, but I hope that you can make out what he's saying anyway. So let's see.
Without having to ask anybody's permission. Hundreds of millions of people are using it freely today. I'm worried that this will end in the USA. I worked on net neutrality before, and so did a lot of other people. But since then, some telecommunication companies have spent a lot of money on TV ads and PR, and the US House seems to have wavered from the path of preserving net neutrality. There's been some misinformation spread out. So here are some clarifications. Net neutrality is this. If I pay to connect to the net with a given quality of service, and you pay to connect to the net with the same or a higher quality of service, then you and I can communicate across the net with that quality of service.
Yes, because of the crapiness of the audio, I'll repeat. So he says that if I pay for connecting to the web, to the net, with some quality of service, let's say bandwidth or something like that, and you do the same, then we can connect to each other using that quality of service. Right? It's not about getting stuff for free. Everybody understands that there's companies that need to provide you with internet connectivity, and they might charge you for that. Right? So it's not about getting it for free, which is sometimes what people think when they hear net neutrality. Everything should be free on the web, and that's not the case. It's not the goal. Right? And it's also not the case that anything should be allowed on the internet. Right? There are things that we want, as a society, agreed are illegal, and we want to be able to say this can't be published. Right? Any sort of, you can think of material that you don't want to be published. Right? So it's also not saying, oh, this is a place that should be free from all regulations. It's just about saying, if I pay for some bandwidth and you pay for some bandwidth, we can connect regardless of what we want to do. Right? So, in other words, and now we get to the technology part, this is looking at the web as a dumb pipe, or at the internet as a dumb pipe. Right? So the pipe should not be, there should not be blockages in the pipe depending on the type of bits that get sent over. And so, in other words, anybody who gives you access to the web should not be able to determine what goes through and what doesn't go through, or which specific type of bits get priority over other bits. So this is the net neutrality principle. And it's a nice principle because that's sort of, if you adhere to this, then apparently your provider can't say, oh, I want to prioritize my own services, for example. Or if I'm a government from some country, that means that I should not be able to, cut off all WhatsApp traffic because my citizens are doing things that I don't like on it. Right? If I'm a net neutral country, then I say you can connect with using whatever services you want, sending out bits and bytes, whatever you like. Right? So that's net neutrality. Sorry. Right. So, what Tim Berners-Lee is alluding to here is a debate about this net neutrality that was specifically in the United States. So there was there was this Comcast issue, which you hopefully read about in the paper, right? Where Comcast was prioritizing certain services that they offered, and you should be able to do that, right? Because then you get these monopolies that vertically determine your access to information. So if you don't want that, right? So let's say that's an unwanted thing. What can we do about it, right? So there was a debate whether we should either let the free market decide, or do regulations, right? And this article talks a bit about the pros and cons. So a reason why you would want the market to sort it out is because actually in the article it works out, right? So at some point the BitTorrent that was cut off by Comcast was being let back in again. Right? So Comcast was claiming BitTorrent is killing our throughput, so we shut down specific bits, which are the bits that are sent through this peer-to-peer network, to prioritize our own services or services that we do like. Right? And in the end, they sort of figured it out. There was a lot of backlash. So you could say, well, the market system worked, right? So it regulated itself. You could also say, this is what a lot of the American senators were saying on the specific side of the aisle. Actually, the internet thrived because of the lack of regulation. Because it was this open information space that businesses could do business on, it actually became as big as it became. So we shouldn't regulate it because it's this thing that should not be regulated. Right? So the FCC was one of the people from the FCC regulatory body in the US was saying this. Right, and they say actually the internet service providers have a vested interest in not cutting off specific services that users want, right? So this is the market principle. If I am unhappy, I should be able to go, I can just go to another service provider. So you can already see we're getting into political debates here, in economical debates. Right, and the other side of the aisle said, well, right, this is a more counterpoint to the second point. Actually, people think about the web as this unregulated free-for-all, but actually the web became successful partly because it was regulated. Right? So like the phone lines, because of standardization and adhering to standards and regulation, specifically in the beginning, the web grew to its current size. Right? So this is why Al Gore is one of the main figures behind the web, not because he invented the technologies, but because he pushed a lot of this legislation that sort of made the political landscape in such a way that it worked. Right, so telephone market, like I said. And actually they say, well, it's not very likely that these ISPs will do that because it's not part of their reasonable network management that they're saying. So there's a lot of pros and cons, and this depends a bit on your political views. Whether you think that market regulation or government agency regulation is a good idea. Oops, sorry. And then there's a question, so how you actually should regulate. This is sort of a third pillar here. So we have the market and we have the governance. And in this article that you looked at, the Weitzner article, they actually sort of say, well, the best option is actually this non-super legal top-down thing, but a more open, engineering-driven, evidence-based standard setting. Right? So this is also something that you see a lot in regards to legal questions on the web. So rather than going back to old school top-down legal things, what we can actually do is try to build new technologies, so to do an engineering approach in combination with sort of flexible legal action. So we see that the web is now changing so fast that it's hard for lawyers to keep up with it and with lawmakers to keep up with it. So rather than doing that, we want to have this sort of rough consensus and running code that is advocated here. And there's a very good internet law professor here. I always forget his name. Okay. You can look him up, Fu Law Computer. And he's one of the people that really subscribes to this point, right? So he's a law professor, but he thinks, well, actually this is something, there's like a more of a flexible way of approaching this with this rough consensus and running code. So that's the interesting way to looking at these regulations and the domain in which they're happening. Okay, so net neutrality has this bumpy ride. The Netherlands is actually one of the first countries to regulate net neutrality and put it in law. So after Chile in 2013, I think, was finalized, the net neutrality was put into Dutch law. So as a service provider, you can't do this cutting off of certain things. However, it's not something that is now done, right? So there's actually a few good reasons why you might want to not be neutral. So one example that I always like is if you get internet in the train, right? So if you use that, it's always super bad. Right? So why is that? Because they have bandwidth issues, so the train needs to communicate with some outside thing. And then there's always the guy sitting next to you who's streaming Netflix or downloading Blu-ray movie over that same network. Right, so if there's a net neutrality, I can't say, okay, well, these guys' bits should go. So we don't do Bluetooth downloading, or we don't do streaming services. We only do important emails because those are more valuable bits. And because NS the Dutch Railways, in this case a service provider, they are not allowed to cut this off in that way. Right? So there you can see actually there might be good reasons why in some cases you might want to think a bit differently about net neutrality. Okay, so another example is, this is one from 2016. So this was quite popularized. So this is in India, where a large part of the populace did not have access to the web. And then Facebook stepped in, Mark Zuckerberg stepped in and said, okay, we're going to give free internet to everybody. But there's a catch. You have to use our services. Right? So they sort of prioritized their own services. So they acted as service provider, and also they had these web services. And interestingly, there was a really big backlash over this policy, and they cancelled it quite soon. Right? So that it was not allowed, and they withdrew. Because of this sort of cancelling of net neutrality, and in the USA, which is where Tim Berners-Lee is calling to the senators in this video that you just saw, there was a net neutrality rule passed, which was then reversed. So, right, you can see this is still a very contentious issue. But to understand net neutrality, you need to understand, let's say, the different layers, right? Because it's this political thing. But it talks about access to the TCP/IP layer, essentially. To be able to have a good opinion about it, you need to be aware of these different layers. Okay, so that's one. And another one is linked open data. And I'll start sort of by talking a bit about the technologies and what we're doing. And then it also leads into the last one, which is how we can use this kind of stuff to solve some of these, or at least address some of the challenges that we looked at before. Okay, so linked open data, or the semantic web, is one of the ways in which we're thinking about the next version of the web, and we've been building it since around 2001, I want to say. And this is also a topic that me, myself, and Jacco van Ossenbrugge are involved in. So I'll just give you a 10-minute primer on what it is. Okay, so this is the recognition that a lot of the data, so we are living in a data-driven society, but a lot of this data is actually in silos, right? So these are individual databases in companies, or subsystems, or SQL databases, or your Excel sheets on your hard drive, or whatever. Which is nice, but there's value in connecting these things. Right? So that's sort of the idea of, we have documents and we want to connect them. Now we have the same for data. Right? So in fact, so the next two slides. So this is the promise of the World Wide Web. So we have a web page, and I put links to other pages, right? And through that, I create extra value for my own web pages. Right? So I make a page about something, I link to a cat page or whatever, and now my page gets more valuable, and we get this network of documents. So this is the World Wide Web in one slide. Right? And the World Wide Web is meant for humans. So you can browse it, and then you can read it, and do something. So that's nice. And then we thought, okay, maybe we can use the same sort of technologies or build on the technologies to do the same, but for data. So not for documents, but for data. Right? So where the World Wide Web is a web of documents or linked documents, the semantic web or linked data is a web of data. So we have these individual databases, and instead of linking documents, we link individual data elements, or data items, things in the database. Can be anything. Like the web pages can be about anything, the data can be about anything. And the idea is that you not just sort of interact with these things directly, but there's applications that can do something with it. Right, and I'll show you an example a bit later on. Okay, so here he is again, Tim Berners-Lee. So if we look closely at the proposal that he wrote in 1989, we can see that there's these things that look like documents, linked documents. Right? So that's sort of what the web became in the years after this proposal. But if we look more closely, we can actually see that it's not just documents, it's also data. So in the original proposal, it was about linking documents and linking data in a big network. And only later did he and we start to focus on the linking data part. Right, so it's a bit newer, and it didn't take off as spectacularly as the World Wide Web, so I'm going to already be a bit cautious about the success of this, but this is something that we are still building and researching. Right, so he is also one of the main drivers behind the semantic web originally. Okay, so how does it all work? Well, how does linked data work? Well, basically it's, again, using these standardized low-level technologies. Instead of linking documents, we now link data, and we use the same principle. So where the web is this network of documents, right? So it's a network thing rather than a big table of all documents that exist, these links. We also do the same for data. So we link data in a graph. And we use, again, a bunch of standards. And some of the standards are shared. So the web of data is built on top of the same infrastructure as the web of documents. So we use, again, also HTTP, for example. We also use URIs. So URLs are, let's say, locations, and URIs are identifiers for the data items that we talk about. And they use the same format, right? So HTTP : / blah, blah, blah. Okay, and then there's a bunch of ones that are specific to linked data. So RDF, RDFA, RDFS, ALS, SCORS, SPARQL, etc. For example, here at VU, we've been one of the key partners in designing OWL. It's one of the technologies that we built. Right? It didn't exist, and then we built it, and now it exists. And so that's sort of, I'm not trying to, I didn't do it, but I was trying to say that these technologies are things that we are building to solve problems that we see or that we want to solve. And the same holds for SCORS, which is also one that VU played an important role. And so this is, we can actually make important changes to the world, to the stack of web data. And these standards are all governed by the same body that governs all these other web standards, including HTML. So this is the W3C. So you've heard of W3C? Yes, good. Okay, right, so they govern also the web of data like they do the web of documents. Okay, so this is the main principles behind data. So one, for everything that I want to talk about, every item in a database, I use a URI, an HTTP URI. So for example, if I'm the Rijksmuseum, if I want to point to a painting, I can give it a URI. So I give, for example, URI rijksmuseum.nl/data/painting 001. Right? And you can do the same for any other type of database. So that's nice because already I get all this stuff for free that the web brings me. Like I can point my browser to it and it will go to some server using the TCP/IP and DNS servers, etc., and I will get something there, right? So what it will get is slightly different from a web page. If you ask for a web page, you get HTML. And if you go to a data URI, you should get this other thing, which is not HTML, but RDF. And RDF is also the HTML for data. Right, and I'll show you what RDF looks like. And then also, to make it a web of data, you need to put a lot of links there, which can be expressed in this RDF format. Right, and by adhering to these simple rules, we can build a web of data, which we can then use applications for to do all kinds of cool stuff with it. Okay, so this RDF is very simple. It's basically a data model Right? Like HTML is a document model, RDF is a data model that is nice because it's so super simple. Basically, all we say in RDF is anything you want to say about anything in the world can be expressed using so-called triples, which are basically subject, relation, object statements. Right? So, for example, if I want to say that this painting has some location relation to Amsterdam, I can make a triple painting 001, and I left out the whole URI part here, has location Amsterdam. So that's a statement stating a fact in the world. Right? So this is nice and it's very simple. And this is RDF, but this is also RDF that now is machine readable. So you can imagine I can write a parser for this and it will work, it will do something. Right? So this is the way that I can write down data. And the nice thing is I can use these things to write down all kinds of local data, but I can also use these to point to identifiers that are out there somewhere. Right? So because now I'm on the web. So if you combine these triples, sorry, I'll just show you this first. If you combine these triples, right, so for example, the green part is in the Rijksmuseum, so I have two paintings and they're both painted by the same person. Right? So this is now nice because I can represent all the data in my database like this. But I can also make a link to some completely different database. So this is in a different namespace all across the other end of the world. This is people that do a lot of geographical data representation, the geonames people. And they know about geographies. So why is that nice? Because if I'm the Rijksmuseum database guy, I don't want to be bothered by writing down all the stuff that I know about different cities in the world. Right? For example, how many inhabitants they have, where it is, if they're part of a certain province. Okay, so that's nice because I can make these links and I get all this stuff for free, just as we get with the web of documents. Right? We have to make a link. I don't have to include the whole Wikipedia page, I just make a link. So we do the same for data. And now you can think that actually an application that is able to read RDF and follow these links, they could, for example, answer queries like, give me all paintings that are produced in cities with more than 100,000 inhabitants. Or, plot all the paintings that we have on a nice map. Right? So you can do all kinds of advanced analyses and visualizations and all kinds of things that you might want to do with data that now, are not longer confined to a certain silo, but actually can cross silos. So that's the web of data. Right, so this RDF, let's have a look at the description on the W3C semantic, the W3C webpage. So it says, RDF extends the linking structure of the web, so it builds on this web and the idea of links, to use URIs, HTTP identifiers, to name the relation between things as well as two ends of the link. Usually this is a triple, right? So this is the core part of the RDF model. Using this simple model, it allows structured and semi-structured data to be mixed, exposed, and shared across different applications. Right? So that's the definition of what RDF is. And there's a whole document. Right? So this is a technology that we built to solve the idea of how do we connect different databases and items in different databases. And then these other technologies that I explained are on top of that, right? So you can express more knowledge representation and do all kinds of reasoning on top of it. And you will see some of that in the rest of your study. So, for example, artificial intelligence, second year we'll do knowledge and data, I think. That's where you will encounter these technologies in more detail. Okay, and the nice thing is we can also look at the web of linked data, right? So we've been building it. A lot of people have been putting web data on the web in this format. And this is a picture that's now a little bit older, but it's a picture of different data sets and the links that are there between them. Right? And if you look at this, you might see, oh, okay, it's a lot or something. But maybe one interesting feature is, again, that we have these things, right? This one, and maybe here. Right? Again, we see clusters forming. So apparently, and this is just an observation, apparently the web of data, to a certain extent, has the same features as the web of documents. We also have this preferential attachment and this exponential network. And indeed, it has this form. Right, so we have, again, these hubs. And one of the hubs, I think the bottom one is, for example, is Wikipedia, which is the data variant of Wikipedia. And there are other hubs, like GeoNames that I showed. There's also one that a lot of people link to because everybody has geographical information. Right? So we can study the web of data the same as the web of documents, as we're building it. All right. So the people built a lot of nice applications on top of it. So the BBC wildlife, the BBC sites were a good example where the pages on the BBC looked very nice, right? They don't look like data, but they use data from all kinds of different parts of the web of data, to provide you with some nice integrated user experience. Right? So as a user, you don't see it; it's behind the screen. That's why a lot of people haven't heard of it. Right, you can do more advanced things. So this is a very nice example that we also collaborated on with a bunch of different biomedical companies, where they have a lot of data about drugs, enzymes, chemicals, all these kind of things. And if you put them all together, you can do drug discovery more easily. You can find out, oh, if this drug works on this enzyme, so maybe it also works on this enzyme, because we know that they're very similar. But the knowledge is now spread out in different silos, and only by bringing them together can we discover new things more effectively. And so this is a sort of a success story about this type of linking data. Another big success story is the Google Knowledge Graph, which you might have seen. So this is the representation of a lot of information that Google holds that they use also in all kinds of services. For example, the info boxes that you get when you search for things. Yes?
So the final goal of this is to basically make a huge relational database that everyone can access, right?
Yeah, so the final goal is to put all the knowledge in the world in this one format, link everything together in this one format, so that everything can be accessed in the same thing. So a relational database is slightly different, because usually you think about tables, and here this is a graph database. So it's one big graph.
And the data is still stored in their original, let's say.
Yeah, so data can be stored in heterogeneous and remote locations. So you need sometimes to have federated queries. And people are thinking, how do we do these things efficiently, effectively, make sure that it works? And these are hard questions, because we don't know. But it's the same as with the World Wide Web, right? So pages also exist on different servers. And then sometimes you need to have services such as Google that maybe index it locally or do something locally. But it works because all the things are distributed and not centralized in one place. Good question. Okay, so the Google Knowledge Graph was a big success story. And actually, Professor Frank van Harbelen has been collecting success stories, because now knowledge graphs, which are essentially just databases in this format, right, are becoming more and more and more popular. And let's say these are companies or institutions that have been working on their own knowledge graph, gathering all this information in a big graph format, most of the time using our standards, the web standards, sometimes using things that look very close but are slightly proprietary, right? But we still claim them as successes. So these, you can see that everybody is doing this knowledge graph building nowadays. All right, so that's linked data. And then for the final 10 minutes or so, I'll show you how because this was mostly about technologies, right? Linked data. But now there's also this view on, can we maybe use linked data to solve some of these issues that we saw in the current web, right? So this is the very new efforts that are being pursued by people like Tim Berners-Lee. So again, we go to a slide from Tim Berners-Lee that he presented here 2 years ago. Right, so he said this from utopia to dystopia, which is Tim Berners-Lee taking responsibility, which I think is a nice thing. He didn't have to do it. Taking responsibility partially for this idea that the web also brought us this dystopia, right? So in the beginning of the web, it was this anarchistic, free-for-all place. Everybody would get democratized, and free speech was rampant, and it was this sort of nice anarchistic place, basically a sort of utopia. And then it was slowly turning into this, there were these other sides of the coin, and we've looked at a few, right? So the politics on Facebook, for example, half of the US countries probably very happy with how it turned out, and half of that is extremely unhappy. But we are now thinking, is this the world we want? Is this the web we want? Right, so this is this realization that the invention of the web has led partly to this. which is one thing that you can study. And Tim Berners-Lee looks at it and is informed of this. But then also ask this bold question and back again. Right? So this is the question: can we do something about it? Can we come up with solutions? And what do these solutions look like? Okay, so one of the solutions that we've been working on is this idea of re-decentralizing the web. It starts with this observation. So there's all these stakeholders, big companies that you all know by name, and you're all using, I guess. And they all have this realization, wait a minute, your data is amazing because we can make a lot of money from it. Right? So your data means we have power, and which means we can make a lot of money. So I don't have to go through all of these examples, but just Facebook, Cambridge Analytica, big scandals. This is not the web we want, right? But there's a reason why this is happening, because it's working, right? It's making them a lot of money. It's making them more powerful. And why would they stop unless they're told to stop, right? So where the web was once a very this anarchistic thing, it's now becoming more of a domain of a few large companies and governments using surveillance machines. So actually, from a very distributed, decentralized architecture, and actually in practice it was also very decentralized. You see that these hubs are becoming more powerful, and they're drawing this data. They're sort of investing in these vertical platforms so they can do everything. Facebook is buying WhatsApp, is buying all kinds of services so that they can do this data analysis at a very large scale. Right, so this is sort of a centralization, the concentration of power, if you want. So the decentralization effort says this is not what we want. Right? And we can disagree with it, maybe we say we want it, but I think most people tend to agree that this is going to a scale where we maybe might be not so happy with this current setup anymore. Okay, so that's realization, observation. And then there's a working assumption that says, well, okay, it's at least partially our fault. And when we say our fault, we say the engineers, the web science people. And there's a responsibility for us to fix it, or at least we should think about how to fix it. And then again, taking the socio-technical approach. Right? It's not just social, it's not just technical, but we can look at solutions from different angles. Okay, so some social fixes might be, okay, we do a lot of awareness. Right? So we have all kinds of privacy awareness campaigns that are either by the government or by interest groups, and try to make you as a consumer more aware of, for example, privacy concerns. Right? So I'm sure you've all been thinking about, should I be using Google and Gmail and Google Maps and, what's Google using for me? And maybe I should change my behavior, right? So partly it's because we are being made aware of these challenges by the journalists, for example. And then the solution is I could stop using one or more services. So who of you uses DuckDuckGo, for example? Right, so 1, 2, 3, something like that. Yes, 4. Very good. Very enthusiastic one. Right, so this is okay. You're made aware of the problem, and you, as a consumer, you can fix it. And then DuckDuckGo offers a service. Right, so this is sort of a free market type of solution where you make some decisions based on your awareness of the problem, which is a social fix essentially. Another fix is, let's say, more technical. It's not really social, but you can use available technologies like VPNs or something to add in front of your tools to make your behavior more like that you want to use. Yes?
How would you make Facebook stop tracking you?
How could we make Facebook
Stop
tracking us?
Yeah.
Yeah, so I mean, there's answers. Again, it can be regulation, right? So we can make regulation or legislation. Right, so it's working, right? So people say, well, it shouldn't do that because internet is a free anarchistic thing. Well, yes, that's what they want you to believe. But actually, if we all vote for the European Union. If the European Union, they make laws that in essence, we want, right? So it's a slow process, but that's how democracy works. And we can say, through a democratic process, we prohibit companies for doing specific things, like tracking, stopping Facebook trackers. That's one solution, which is the democratic solution. Another solution is by installing all kinds of plugins and security patches on your own setup, right? And maybe that's not for everybody, but that's one solution. So, yeah.
But laws are made by governments or like entities at the European Union, and they are actually exploiting data from websites like Facebook and.
Sure, you should vote them out. I mean, I understand this is not as easy and it's not immediately, but this is the democratic process, right? We see something that's going wrong. It's being signaled by journalists. We get angry as a people. We vote a certain way, and things change. Hopefully. Of course, there's other powers that go counter to this, and one is time, for example. This takes a long time, but this is one way of doing this. And legislation is successful, right? So we can force companies to do things that they maybe don't naturally want. So it's not completely an insane idea. Right, so these are sort of different things that we have, but one other way of looking at it is by inventing technologies that can actually give you an alternative as a consumer, right? So people say, well, I don't have an alternative to Facebook. I want the things that Facebook gives me. What do I switch to? Right, so one thing that we can do is give you some options, or at least come up with technologies that then companies can expand on and give you options. And one of these solutions is called Solid, which is a technical fix to this issue. And Solid is a company, a spin-off company from MIT, and you know who is one of the people there. It's Tim Berners-Lee, of course. And Solid has this idea. Solid is derived from social linked data, right? So they use linked data. It's a proposed set of conventions and tools for building decentralized social applications based on linked data principles. It's modular, extensible, and W3C compliant. Right? So they say, okay, we're going to build these social network facilities using linked data properties. Right? So now, hopefully, now you see how those things magically come together. Okay, so how does it work? So instead of hosting your data at the service provider, so if you upload anything to Facebook, it all gets hosted somewhere in the US. You have to play by US law, and they get to do with your data whatever they legally can get away with. All right, so that's this thing. It's a centralized solution. So instead of doing that, we do the other way around. So you host your own data. Maybe it's not on your own server that you have hooked up to your cable. Maybe it's a service provider you pay here in the Netherlands that you trust, right? So that's the setup, but it's at least decentralized. And then companies like Facebook can use that data insofar as you allow them to, and exactly the data that you allow them to. So by decentralizing it, the idea is that you get much more control over what companies can do with your data. Right? So we can theoretically give the same services, but in a much more decentralized and controllable way. By taking away the separation of concerns, right? No longer is there one player that hosts, delivers services, does data analytics, etc., etc. No, we now say, I want to host my photos there, I want to do sharing of my social status there, and you can separate those concerns. And the idea is that your personal data, all the data that you provide are in these personal pods, which are PODs, and they're all RDF, right? So that's just a technical solution. Right, and then you get these nice things. This is from their webpage. I'm not going to go too much into detail here. And there's people that are working on it, so they're developing it now. Right? So these Solid applications. It's there, you can download it, it's open source, you can have a look and build your own applications. Tim Berners-Lee is there. Rutger Borg, who's a professor at Ghent University, is also involved. And there's a Dutch community in Solid that you can get involved with, and I'll show you how. Okay, so that's nice, right? So again, it's a technical solution for a social problem. And that's interesting, right? So I don't think you see a lot of those things in other types of sciences. Okay, there's all kinds of challenges. So how do we know that data is trusted? How do we know that data is true, right? If it's so distributed. And maybe that's a sort of a technical thing, maybe. But also, how do we convince companies like Facebook or maybe other companies? Where's the money in for them? Right? Facebook is delivering you all these free services, not because they're nice people. They might be nice people, I don't know. But because they actually earn money, right? So their business model is, we give you all this cool stuff for free, and then we get to get all your data and do all kinds of things that make us money. Right? Everybody's happy. Right? So that's a business model. So what's the business model for using, your PODs? So maybe that means that you have to go back to paying for services. Is that something that you want as a consumer? I don't know, it depends. So this is one of the reasons to be skeptical, but what the people from Solid say is there's basically only one alternative now. There's only one model that's working, which is to give me your data and I'll give you services model. Right? And there might be other models, but now technically they're prohibited from existing. So at least we should put them out there and then see if this is a sustainable business model. Right? So that would be the value proposition there. Okay. Like I said, if you think I'm super interested in this decentralization, there's actually a meetup here in 2 weeks, on the 30th of January at the VU. So the link is in the slides, which I put on Canvas soon. So you're most welcome. I'm only involved from the side, but this is really something that is not, let's say, from a purely academic background, but these are really sort of companies and activists that are interested in this technology and that started this meetup. So just to show that this is something that's really new and comes from this scientific thing, this linked open data, and is now being taken up to solve these social web issues. Okay, so that was it, my final slide, so take home, just to hammer home some of the points that I tried to make. So web science is a new type of science that recognizes that this thing that we've built that is worth studying it. And it studies what people do on the web, the technologies, and more specifically the interaction. And I hope that it's something that you saw through the examples that I gave you today. Okay, so it's multidisciplinary, it talks about ethics, business, law, etc. And also I think one of the most important things for me is that it's not just a way of observing things. You cannot just do studying, but you can actually also change it because we're also engineers. So good luck. Hope to see you all at the Solid meetup, or maybe 2 or 3. And I'll see you soon. I understand that Jacco will discuss assignment 3 in the afternoon lecture. So good luck with that.